The question says, why is benzene extraordinarily stable though it contains three double bonds? Okay, just to confuse the students, it is mentioning three double bonds are there. In double bonds, pi bond is there, and pi bond is weaker than sigma bond, so pi bond can be broken. So it is supposed to be more reactive, but it is having more stability, extraordinarily stable. Okay, so first of all we can draw the structure. Okay, for benzene we have benzene ring. This is what we have, benzene ring. Okay, one pi bond, second pi bond, and third pi bond is there. Okay, you can see in this benzene structure we have double bond, single bond, double bond, single bond, double bond, single bond. Conjugated system is there. Conjugated system. Okay, this is the plus point. Any system in which conjugation is there, resonance will be there, and we have learned higher the resonance, higher is the stability. So one factor we have, this benzene ring is having conjugated system, hence it has resonance also. And you might have learned about the resonating structure. Okay, so one structure we get something like this, resonance. So double bond will come here, double bond will come here, double bond will come here. Okay, so this form can be converted into this form via the resonance. You might be knowing about this, we don't need to discuss about the resonance. Okay, and since this pi electron density is circulating via resonance, so hybrid structure is represented in this form. This electron density is representing. Okay, this is circulating, circulating in this planar structure. Okay, so like this it can also be represented. Okay, so it has a conjugated system, resonance is there, so this is one of the factor for the stability. And another factor you might have learned about the aromaticity. Huckel's rule is there. Huckel's rule. We have Huckel's rule is there. Huckel rule. Okay. This person says that 4 pi plus n, 4 pi plus 2, and it is 4n. The form. Let me correct this formula. It says 4n plus 2, and in the bracket we have pi there, where n value can be 0, 1, 2, 3 is there. Okay, if you plug in the values you will get 2 pi electron, 6 pi electron, and then we'll get 10 pi electron, then 14 pi electron in the gap of 14 pi electron, or if I take 1, 4 to 6 pi electron in the gap of 4, 4, 4, 4, that is correct only. Okay, in the gap of 4 we are getting. Okay, so any system in which these pi electrons are present, and each carbon is square planar, having planar geometry, and it has conjugated system, then it will have aromatic characters. What are the conditions? This guy says that conjugated system should be there. Conjugated system, benzene has conjugated system. Each carbon should be sp2 hybridized planar structure, and then it should have 2 pi electron, yeah, maybe 6 pi electrons, or it can have 10 pi electron, like that. So you can see if all these conditions are met by a compound, so it will have aromaticity. It will be highly stabilized by aromatic characters. Okay, so this is also adding another factor for the stability of a benzene ring. So you can see this carbon is forming how many sigma bond? One hydrogen is attached because carbon is forming 3 bond. One bond, second bond, third bond. This is the fourth bond. So this is sigma bond, this is sigma bond, this is sigma bond. So you can see this carbon is forming how many sigma bond? 3 sigma bond, 3 sigma bonds. This is what sp2 hybridized. Okay, similarly each carbon is attached to one hydrogen, and each carbon is what? Sp2 hybridized, because each carbon is forming 3 sigma bond. Okay, so you can see we have planar geometry is there. Planar structure we have for the benzene ring. Conjugated system is there. If we calculate pi electron, so you can see one pi bond has 2 pi electron. This is another pi bond, this is next pi bond, 2 pi electron, and then we have 2 pi electrons are there. The total 6 pi electrons. It gives us 6 pi electron are there. You can see 6 pi electrons are there. Any of these electrons present in a system. Okay, so we got 6 pi electron, conjugated system, sp2 hybridized carbon, planar geometry. So this is another factor adding up to the stability of the benzene ring. Okay, so by resonance also, by Huckel's rule also, we can justify the extraordinarily stability of benzene ring, despite the fact having 3 double bonds. If you like this video, please share and subscribe to the channel.